Okay, welcome back. This is the second video I'm going to do on the limiting reactant. This is another problem from your book. So this is 3.73 in chapter 3 of your book. And in this case, you're going to have an Alka-Seltzer tablet dissolve in water. Okay, so you're going to have, here's the reaction actually, sodium carbonate plus this is the citric acid, H5O7, and it's going to make carbon dioxide gas plus water plus 366 H5O7. Ugh, that's ugly. Really, I only check out this. I've got a 3:1 to 3:3 to 1 relationship. So I'm not interested in all of this or how ugly it is or how big it is. If you give me two of these products or two of these reactants, a certain amount of grams, I'm going to compare them to see, I'm just going to pick a product and see which of these two reactants that I'm given is going to make less. Whichever makes less, that's the limiting reactant. Whatever I have more of left over, that's not limiting. Whatever I use completely up, that's going to be the limiting reactant. So here's the example. In a certain experiment, 1 gram of each of these is given. So 1 gram of the bicarbonate and 1 gram of the citric acid is what is given. And you're asked, first question, which one is limiting? Okay. Well, let's pick one. This is a 1-to-1 relationship, so I could pick these two. I could also pick water. That's a 1-to-1 relationship. That's nice and easy. It saves me a step. Remember, this relationship is in moles. This is saying 3 moles plus 1 mole yields 3 plus 3 plus 1 moles of the product. So I have to go into moles before I can compare anything. So I'm going to say in 1 gram of the bicarbonate, how many moles is that? Okay, so this is pretty big. You've got a sodium, hydrogen, carbon, and oxygen all together. So let me find a periodic table. That would be nice. Okay, periodic table. So I need to add all these up in order to find out what the molecular mass is. And I've got that sodium is 23. So I've got one of those, 1 times 23. I've got 1 hydrogen is 1. I've got 1 carbon is 12. And I have 3 oxygens. That's equal to 48. So what's the whole thing? Okay. 48 plus 12 plus 1 plus 23 gives me 84 grams per mole. So this is 84 grams of that. All right, so 1 divided by 84 is going to give you 0.01 moles. So if I have 1 gram of the sodium bicarbonate, okay, baking soda, how much, so that's 0.01 moles of this, how much carbon dioxide can I make? Well, it's a 3 to 3, so it's a 0.01 to 0.01. So that means that I would make 0.01 moles of the carbon dioxide. Well, let's see how much the citric acid would yield. Okay, we want to know which is going to make less of this. Okay, so let's start again. 1 gram of the H3C6H5O7. Okay, so this is, let's find out how much this is. 6 times 12 equals 72. This hydrogen is 5, 6, 7, 8. So 8 times 1 is 8. And then 7 times 16 is 112. Plus 8 plus 72 is 192. So this is saying 192 grams per mole. Okay, so 1 divided by 192 equals 0.005 moles. Okay. Well, we want to do the carbon dioxide again so we can compare them. We know that the other one made 0.01. How much can this make? Well, this isn't a 1-to-1 relationship, so this is a 1-to-3 relationship. So we're going to have to say 1 mole of the citric acid over 3 moles, so this is citric acid, of the carbon dioxide gives, how much of this did we have? 0.005 moles of the citric acid. How many moles of the carbon dioxide? So we cross multiply. 1 times x is x, and 3 times 0.005, and I have x equals 0.015. Ooh, that's very close, because we saw this was 0.01, this is 0.015. Let me do this one again just to make sure what the decimal is. I have 1 divided by 84 equals 0.012. This is 0.012, so this is 0.012. So with 1 gram of the baking soda, I can make 0.012 moles of the carbon dioxide. With 1 gram of the citric acid, that's the tangy stuff in the Alka-Seltzer, I can make 0.015 moles. So which is bigger? Citric acid is bigger. So what's the limiting reactant? The baking soda. So we're going to say sodium bicarbonate is the limiting reactant of this problem. So what else are they going to ask us? They're probably going to ask how much is left over of my excess, how much I can make of a certain thing. So let's do this again. So the number B says, how many grams of carbon dioxide form? Ah, that's good. That's what we wanted. It's carbon dioxide. We know it's 0.05 moles of, that's the bigger. We want to use the smaller, because you can't make any more than your smallest amount can make. So that means we're going to make, putting these two things together, we're only going to make the small amount. We can't make the bigger amount. So we're going to say 0.012 moles of carbon dioxide. 1 mole of carbon dioxide is how many grams? Well, carbon is 12, there's one of those, and then 2/16, that's 32, so that's 44 total, so that's 44 grams per mole, times that's going to give you 0.52 grams of the carbon dioxide gas. So that's your B. How much can you make? You can only make 0.52. Okay. So here was the first one. This is number 1, limiting reactant. This is the second question. How much can you make of the carbon dioxide? That's how much you can make. And then the last question is, how much of the excess remains after using it all? Okay. Well, if this is the limiting reactant, then this must be the excess reactant. Okay. So how much are you going to use? Well, this is a 3-to-1 relationship. Okay. We know that we made 0.012 moles of this. So how much of this did we actually use? So let's just go backwards. We're going to say this is 3 moles of carbon dioxide gas to 1 mole of citric acid. And then this was 0.012 moles of carbon dioxide gas. How many moles of the citric acid were required? So this is 3x. 3x equals 0.012. 0.012 divided by 3. X equals 0.004. So this is 0.004. This is how many moles that I made, or this is how many moles that I actually used. How many moles did I have? Okay, with 1 gram, how much is that? Okay, well, that is 0.005. So this is how much I had total. This is how much I used. The rest is left over. So I'm just going to subtract that. 0.005 minus 0.004, and I bet it's 0.001. Well, look at there. This is 0.001 mole, 0.001 mole of the citric acid left over. And if they want to know how many grams that is, we have to go through the periodic again. This is moles. And in 1 mole, there were 192 grams, which equals 0.192 grams left over. So this is number 3. Okay. So you're going to see that the sodium, the baking soda was the limiting reactant, how much was left over, and then, or how much that you made of the carbon dioxide. They chose one of the products, and then how much of the citric acid, which was your excess reactant, was left over when everything was used up. Okay, this is very hard, and we'll just do as much as we need for you to learn it. Okay, I'll see you in class.